Okay, so today we're learning about trigonometric functions of compound angles. Compound angles are just when we look at the addition or subtraction of two different angles within our trig ratio. Now, there's a number of different proofs to prove these compound angle formulas. If you're interested, it is here, but for simplicity, I'm going to gloss over that and just show you the rules and how to use them. So, the six compound angle formulas, or really there's three, but the six compound angle formulas look like this. So, our first formula is that sine of alpha plus beta is sine alpha cos beta plus cos alpha sine beta. Cos of alpha plus beta is cos alpha plus beta. Cos alpha cos beta minus sine alpha sine beta. And finally, tan of alpha plus beta is tan alpha plus tan beta on 1 minus tan alpha tan beta. Now, we also have these same rules, but instead of having a minus. So we can see that we can have sine of alpha minus beta. And we can see that it's the exact same formula, but all that's changed, there's a minus here. So when we have our sine, don't know what happened there, but when we have our sine, so sine of alpha minus beta, we might notice that this and this are the same, and we'll notice up here that there's a plus here and a plus here. But when we have our cos, we've got a plus here and a minus here, and here we've got a minus here and a plus here. So with cos, the sign is opposite of what it's given in the original bracket. Tan follows a similar story. We can see that we've always got the same sign on the top. So we've got a plus on the top and a minus along the bottom, a minus on the top. But we have the opposite sign on the bottom. So we've got a minus on the bottom when we had a plus in the brackets. And when we have a minus in the bracket, we've got a plus on the bottom. So these formulas, I really need you guys to remember them. Some of them are on the formula sheet, not all of them are on the formula sheet. And as I said before, if you use your formula sheet, it's really taking up time in the exam that it just makes it easier to remember the formulas. It makes your life a lot quicker and a lot easier. So I like to remember these formulas using these little quotes. So number one is sine is sociable. It's always socializing with a cos, and I remember social sine, same sign. So up here, we can see that my sine is always hanging out with a cos. My sine is always hanging out with a cos, and it's also the same sign. So social sine, same sign. Number two, cos is antisocial. We can all relate to cos. It only is next to other causes. So antisocial cos, different sign. Here we can see up here in our rule, the causes are only hanging out with other causes, and the sines are only hanging out with other sines. And there's also a different plus or minus, a different sign in the middle here. There's a plus here and a minus here. So the two things I like to remember for the formulas are social sine, same sign, and antisocial cos, different sign. I haven't really come up with one for tan. If you can think of one, let me know. But really, you just got to remember the tan one. Okay. So we can use these formulas to expand trig functions. So sine of x minus y, remember, social sine, same sign. So my sine of x is hanging out with my cos of y, same sign, minus sine of y cos of x. Notice here that the x's and the y's, first of all, are with the sine and the cos, but in the second lot of it, they swap, and the y is with the sine and the x is with the cos. Okay. Part B, remember cos is antisocial, different sign. Antisocial cos, different sign. So cos 2a, cos 3b, plus, different sign, minus sine 2a, cos 3b. Okay, part C. Remember sine is social, so social sine, same sign. Sine of 3 alpha cos of 5 beta plus same sign, sine 5 beta cos 3 alpha. Now I might just add a part D there. Let's add tan of, I don't know, beta plus gamma. Well, using our tan rule, it's going to be tan of beta plus tan of gamma over 1 minus, so remember if you've got a plus here, there's a minus down here. So 1 minus tan beta tan gamma. Okay, going back the other way, express as a single trigonometric function, cos x cos y, sine x sine y. I'm first of all noting that my coses are hanging out with coses and the sines are hanging out with sines, so that makes it a cos. I know that I've got an x here and a y here, and remember cos is antisocial, it's also got a different sign, so there's a plus there. It's really cute, that one. Okay. One of the more useful applications of compound angles and their formulas is finding exact values. So whenever we see these questions, find the exact value of sine of 75. Well, we can only find the exact values with 30, 45, 60, and 90. So we're going to ask ourselves, is there any way I can add 60, 45, 30, or 90 to give 75? And we only want to choose two options because our compound angles have an alpha and a beta. They have two angles. Well, okay, 45 plus 30, that's 75. So I'm going to say this is sine of 45 plus 30. Then we're just going to use our theorem. So social sine, same sign. Sine of 45 cos of 30 plus sine of 30 cos of 45. Now, sine of 45 is 1 on root 2. Cos of 30, I believe, is root 3 on 2. Just let me double check on my calculator. Oh, it should be in cos of 30 is root 3 on 2. Yep. Plus sine of 30 is a half, and cos of 45 is 1 on root 2. So here we've got 1 on 2 root 2 plus, root 3 on 2 root 2 plus 1 on 2 root 2. Plussing that together, we get root 3 plus 1 on 2 root 2. Now we rationalize the denominator by timesing the top and bottom by root 2 on root 2. We get root 6 plus root 2 on root 2 times by 2 root 2 is 4. Okay, part B. Same idea, we're just going to say this is cos of 45 plus 30. So this is cos, remember cos is antisocial and it's different sign. Cos of 45 cos 30 minus sine 45 sine 30. Cos of 45 is 1 on root 2. Just something that you might have forgotten from year 10. Cos, whenever you have 45 degrees for cos and sine, it's always 1 on root 2. And same idea, if you have a right angled triangle and you have 45 degrees as one of your angles, that means the adjacent and opposite sides are always the same. 1 on root 2, cos of 30 we figured out was root 3 on 2, minus sine of 45 is 1 on root 2, sine of 30 is a half. So this is root 3 on 2 root 2 minus 1 on 2 root 2. Making that a single fraction, it is root 3 minus 1 on 2 root 2. Writing the denom, we get root 6 minus root 2 on 4. Alright, hope that makes sense.